Hey guys, welcome back to another episode of Robotics with the Barnabas Rover. Today what I want to do, I want to dive a little bit deeper into the driver board. So up to this point, what we've been able to do is create functions that would turn on one motor, the other motor, and then also both motors at the same time. Now when we're able to do that, we're able to make our car go forward, backwards, and then if we've experimented, we're maybe able to get it to turn, that kind of thing. Now, one of the questions that has come up during our class is, what happens if my car's not going straight? So most of the time, the reason that your car is not going straight is because one of the wheels is going faster than the other. And the reason for that is because these components are not perfect. The driver board isn't perfect. It could behave differently for both for both motors. The gearbox, this yellow part of the motor, could be different from this one to this one, and then even the motors could behave differently. These the DC motors right here. So there are imperfections with a robot like this, and also even expensive robots, they will also have imperfections. So that's not a big issue. The thing we need to learn though is how do we fix that? How do we compensate for that? And so if one of the motors is slower or faster than the other, what we need to do is change the speeds so that the speeds match. So up to this point, we're only able to turn the motor on and off. So what I'm going to show you today is how to not just turn a motor on, but actually change how fast the motor goes. Okay, so let's first review how DC motors work. Okay, DC motors, right? So a DC motor, if we remember, it has, here's my DC motor. It's got a plus and a minus. So that's signified by the black and red wire here. Red is usually plus and black is minus. All right, so you have a plus and a minus. And so what happens, these are my two. And why don't I use different color here. Red and black. Okay. So what we learned in the past, right, is if you give it voltage or power, okay, you give it a voltage and you connect it like this, current's going to flow through and your motor is going to turn on, okay? And so up to this point, that's what we've been doing, okay? Now if we remember, going back to the code, right, and this is my pin setup from my previous code. Motor B, it has pin 10 and 12, and motor A has pin 8 and 11. So these two pins, I call them friends, so 8 and 11 are friends. They control the voltage going into motor A. Now for motor B, the friends that control the voltage are 10 and 12. All right. So how does that play into this, into our drawing here? So let's just talk about motor A, right? So motor A is 8 and 11. Let's go back here. So I'm going to remove some of this stuff for now. Okay, so I'm going to say this is motor A. And we have 8, right? Pin 8 was one of the friends, and pin 11. Okay. So let me show you what happens, okay? So in the past, we would say, let's see, I'm going to try to draw a chart right here. Pin 8. Pin, sorry, a little crooked, 11. And then MA stands for motor A, like what it does, okay? So what we would do is we would, well, let's look at our code. We would say, like motor A forward, right, was 8 was low and 11 was high. So if pin 8 was low, L, and 11 is high, what happens? Our motor A goes forward. And then we also learned, this is just review, if we flip that, if we say pin 8 was high and pin 11 was low, then we get backward. Okay? And then we also learned that if they're both high, it stops. If it's both low, it also stops. Okay? Okay, so now this is all review. Now, I'm going to replace low with something and high with something. All right, so low is actually zero. Okay, it's a zero voltage level. Okay, now what is high? And I'm going to talk in terms of the way that the Arduino is programmed. It'll make a lot of sense a little bit later. High is 255. So I'm just replacing all those H's with 255. Okay. So what's going on here? Why am I doing this? I'm doing this because I'm going to introduce to you a new command. In the past, we would use digital write, right? Now, what we're going to use now is called analogWrite. Analog. So what's the difference between digital and analog? Well, basically, digital, there's only low or high, right? That's why in the past we would just say digital write low or digital write high. So you can only have off or on. So super easy, but you're also very limited. You can only go off and on. What if you want like half on, or if you wanted like 3/4 on? Then you need analog, okay? And so that's the big difference. With analog, you can get all the in-betweens. With digital, you can only have on or off. Now with analogWrite, what is the highest number that you could use? It's 255. I won't get into why it's 255 for this lesson, but just know for analogWrite on the Arduino, the maximum is 255. All right, and so that's the same as high. So that's the highest. Now, what's the lowest? It's 0. So that's why for low, we replaced it with 0, and for high, we replaced it with 255. Okay, so what does this all mean here? Well, whenever we have, remember, pin 8 and 11, right? They control motor A. Pin 8 and 11 actually control the voltage, which is the thing that determines the speed, okay? The higher the voltage, the higher the speed of the motor. Now, how is voltage calculated? It's basically the difference between pin 8 and pin 11. So, right now, if we make our motor go full speed ahead, we say 8 is 0 and 11 is 255. Now, what if I want it to go half speed ahead? What's it going to look like? I got to cut it in half. So I would say something like this. Instead of 255, maybe I say 125. 128. And so what's going to happen is that I'm going to say half forward. All right, because now you can go half speed. And remember what I said, how is voltage calculated? It's really the difference between the pins. So 128 minus 0 is 128. Before it was 255 minus 0. So 128 is less than 255, so it's going to be slower. Now, just keep in mind, when I say 128 minus 0, it's not 128 volts, okay? For now, just know that it's not 128 volts. So what's actually happening is these numbers are going into, not directly into the motor. Remember, there's this thing. I'll put this thing here. It's the DB for driver board. Remember, I'm pointing at it with my finger on the top right there. This driver board. This driver board translates these numbers, this 0 to 128 or 0 to 255, into an actual voltage that the motor uses. Okay, so I just don't want you to get confused. Like when you say 128 here, it's not 128 volts. It's just it's a value that your driver board uses to convert into an actual voltage that goes to the motor. All right, so that's the theory behind this. A lot of times, this might be like, why are you teaching me this? Well, the reason that I want you to learn is that I want you to have an idea, just like conceptual idea in your brain of what's going on here. It might look confusing at first, and a lot of times engineering is like this. Like the theory seems very complicated, right? And it could be sometimes, but then what helps is that when you actually play with it, when you actually try it, it starts making a lot of sense. Okay, so let's see if we can make this make sense. All right, so I'm gonna go back to my code here. All right, and I'm gonna say motor A forward. Okay, that's cool. I'm gonna say analogWrite 8. Remember, low was 0, right? And then analogWrite 11. High was 255. Okay, so this should just go maximum speed forward for motor A. So, okay, my code's commented out. I'm just gonna test it. All right. So this should go maximum speed forward for motor A, which is this motor. All right, let's make sure that this works. Okay, it's going forward, max speed, cool. Now, remember I said, now if I want to go half speed, let's go 128. See what happens here. Yes, it's definitely slower. And let's see how slow we can go. Let's go like 100. See if it still goes. Oh, it won't. It's very weak. I could stop it with my fingers. So it's interesting. Maybe half speed is actually the lowest speed it can really go. Let's test that 128 again. Yeah. So what happens is I can slow it down with my finger, but it keeps going after I let go of my finger. Whereas before, with 100, it would just I could just stop it. So I would say 128 for me is probably the lowest. Now, why is it? How come I can't go lower than that? Well, so remember I said the driver board, this thing right here that I'm pointing with my finger, okay? The driver board converts this number, like 128, into an actual voltage that goes into this this motor here. Now, what's going on is that this motor has a minimum voltage. So I'm not exactly sure, but I think these motors, they actually, some of these they're 6-volt motors, and so what that means is that they run the best at 6 volts. Now, the voltage going into the driver board is 5 volts because we're connected the VCC. This red wire goes to 5V on the Uno. So this driver board is getting 5 volts. So when I do this 255, when I put that maximum voltage, maximum number here, it will probably be around 5 volts that it's sending to the motor. So that's already, if it's a 6-volt motor, it's already a little bit less, right? So, you know, you're kind of like still, it's probably good. It's definitely good enough, right? But you're not even at the best voltage. Like, you probably want 6 volts, you know, in the best case. Now, when I do this though, but it still works. So if I do 128, I'm guessing if 5 volts is on the red one, the VCC is 5 volts, then half of that is 2.5, right? So maybe when I put 128 here, 2.5 volts is going to the motor. Now that is not a lot of voltage, especially if the motor is looking for 6 volts, which is maybe why the motor is super weak at half voltage. So that's, again, just some background information, so you guys can understand what's going on. Like, how come when you put half, the motor doesn't even move? You know, you would think like half, like it should move, right? But that's why. It's because this motor is probably a 6-volt motor, and so when you're putting 2.5 volts into a 6-volt motor, you're not getting much much juice into it. You know, it's not really going to perform very well. Okay, so now that we know about that, 128 is probably the slowest we want to go. Let's take this to the next step. I'm going to pause this. Okay. Oh. Hold on. All right. One second. Let's send this over. One more time. Okay. So now that we know that, let's do this. I'm doing motor A forward HS for high speed. Okay. And then I'm gonna change it to 255. And then I'm gonna copy this. Do move LS for low speed, which I found, I think 128 is probably a good number. Okay, and then now let's see it move. So let's write a program where it runs in both speeds, right? So I'm gonna say motor A forward, HS for 1000, then motor A forward LS low speed for 1000. Okay, cool. Let's make sure this works, and let's see if you can tell in the camera. Yeah, it's definitely moving between the two speeds. And, you know, I'm curious now. Maybe let me try 110 so you can see it even slower for the low speed. I guess 110 works okay too. All right, there we go. So we got 2 different speeds controlled with the motor. All right, so you know what? I'll just pause there for now, and let's talk about some challenges. Okay, I'll disconnect this. Let's talk about some challenges here. All right, challenges. Number 1, create LS and HS subroutine for motor A. Just like exactly what I did here in this demo. All right, and then number 2, create low speed and HS subroutine. So low speed and high speed routine for motor B. Okay, and then let's incorporate something with a button, right? So let's say this. Create LS and HS subroutine for moving forward. Okay, sorry, not the button yet, but let's first do this. So the button will come later. So I want you to make a low speed and a high speed subroutine for moving forward. So you have like move forward, so moving both wheels, right? High speed, and move forward, low speed. All right, and then same thing. Since HS and LS and HS subroutine for moving backwards. Okay. And then what we're going to do is, let's see, we can do something with the button. Okay, so first one with the button is when you press, it moves forward high speed. Not press, when you don't press, it moves forward low speed. Okay, that should be not too hard, I think. You know, we're pretty experienced with the buttons, so I think you guys totally get that. And then number 6, and this is something that applies to what you guys have been working on and trying to navigate with the car, is adjust motor A and motor B, HS and LS subroutines. You know, I realize I'm using these two different terms here. It's function and subroutine. So subroutine is same as function. So let me just replace that. So it's, sorry to confuse you guys. Subroutine is same thing as function. So I'm just gonna update this. Adjust motor A and motor B high speed and low speed functions so that the robot goes perfectly straight. Okay, so I want you to think about how that needs to be done. Now everyone's will be different, so your high speed and low speed functions will be different from somebody else's. All right, so once you're able to do that, you get a perfectly moving, straight moving robot that goes high speed and low speed. I want both of them, when it's low speed and high speed, to be going perfectly straight, and I want to be perfectly straight forward and perfectly straight backwards. All right, so give that a shot. You might, if you don't get quite there, that's okay, but get as close as you can, and at least forward. Backward is a little bit tougher to get perfectly straight, so give that a shot, and I look forward to what you guys come up with.